day. Super hexagon? Do you know that using simple hexagon, you can remember a lot of formula and trigonometric identities? Yes, it does. All you have to do is to understand how it will work. But before I proceed, if you think this video will help you to understand mathematics, please do subscribe, like and share, and hit the notification bell. Let us draw a hexagon with 3 diagonal and number 1 on the center. As we are drawing the hexagon with 3 diagonals and number 1 on the center, let us mark the 6 vertices. Remember this formula. Tangent is equal to sine over cosine. Level each vertices of hexagon by trigonometric function in clockwise direction. Start from tangent, sine, cosine. Then opposite of tangent is cotangent. Then what will be next? Divide the hexagon by vertical line on the center. And remember that all on the right side are C. Then only secant is missing. In clockwise direction, mark the 3 trigonometric functions. First is equal to second over third. Tangent theta is equal to sine theta over cosine theta. Sine theta is equal to cosine theta over cotangent theta. Cosine theta is equal to cotangent theta over cosecant theta. Cotangent theta is equal to cosecant theta over secant theta. Cosecant theta is equal to secant theta over tangent theta. Secant theta is equal to tangent theta over sine theta. That is in clockwise direction. But how about if it is counterclockwise? Don't worry, the pattern will not change. Let us try. Tangent theta is equal to secant theta over cosecant theta. Secant theta is equal to cosecant theta over cotangent theta. Cosecant theta is equal to cotangent theta over cosine theta. Cotangent theta is equal to cosine theta over sine theta. Cosine theta is equal to sine theta over tangent theta. Sine theta is equal to tangent theta over secant theta. And that is in counterclockwise direction. So in this pattern, we have 12 trigonometric identities. But wait, there is more. If we have three trigonometric functions, and if we multiply both ends, the product is the middle function. Secant theta multiplied by sine theta is equal to tangent theta. Tangent theta multiplied by cosine theta is equal to sine theta. Sine theta multiplied by cotangent theta is equal to cosine theta. Cosine theta multiplied by cosecant theta is equal to cotangent theta. Cotangent theta multiplied by secant theta is equal to cosecant theta. Cosecant theta multiplied by tangent theta is equal to secant theta. We have another 6 trigonometric identities. But wait, there's more. Again, let us draw the hexagon with 3 diagonals and number 1 on the center. Let us mark the 6 vertices. Start from tangent, sine, cosine. Then opposite of tangent is cotangent. Then what will be next? Divide the hexagon by vertical line on the center. And remember that all on the right side are C. Then only secant is missing. Let us read the functions from one function to the opposite function. It will cross number 1. That is why 1 is there. Tangent theta is equal to 1 over cotangent theta. Sine theta is equal to 1 over cosecant theta. Cosine theta is equal to 1 over secant theta. But what about if the arrow changes its direction? Cotangent theta is equal to 1 over tangent theta. Cosecant theta is equal to 1 over sine theta. And last, secant theta is equal to 1 over cosine theta. And those are the reciprocal identities. But wait, there's more. Again, let us draw the hexagon with 3 diagonals and number 1 on the center. Let us mark the 6 vertices. Start from tangent, sine, cosine. Then opposite of tangent is cotangent. Then what will be next? Divide the hexagon by vertical line on the center. And remember that all on the right side are C. Then only secant is missing. Let us multiply the two functions on the opposite side. Tangent theta multiplied by cotangent theta is equal to 1. Sin theta multiplied by cosine theta is equal to 1. Cosine theta multiplied by secant theta is also equal to 1. And we have now the product of the opposites. And that's another 3 trigonometric identities. But wait, there's more. Let us draw a horizontal arrow. Sin theta is equal to cosine of 90 degrees minus theta. Tangent theta is equal to cotangent of 90 degrees minus theta. Secant theta is equal to cosecant of 90 degrees minus theta. About if the arrow changes the direction? Don't worry, the pattern is still the same. Cosine theta is equal to sine of 90 degrees minus theta. Cotangent theta is equal to tangent of 90 degrees minus theta. Secant theta is equal to secant of 90 degrees minus theta. And these are our complementary angles. Is that all? No, there's more. We know that the hexagon has 6 triangles. Concentrate on these 3 triangles. Suppose we have clockwise arrow inside of the triangle. We can read as sine squared theta plus cosine squared theta is equal to 1. 1 plus cotangent squared theta is equal to cosecant squared theta. Tangent squared theta plus 1 is equal to secant squared theta. That is clockwise direction. Clockwise direction. What about if it is counterclockwise direction? Don't worry, the same pattern, but since it is counterclockwise, the positive will become negative. 1 minus cosine squared theta is equal to sine squared theta. Cosecant squared theta minus cotangent squared theta is equal to 1. Secant squared theta minus 1 is equal to tangent squared theta. And these are our Pythagorean identities. Imagine we have a lot of formula and trigonometric identities using super hexagon. I hope you enjoyed this. And if you want to know the techniques, do not memorize. Just remember and understand how we did it. And always remember how to draw the super hexagon. Thank you. And if you enjoyed it, don't forget to subscribe, like and share, and hit the notification bell. Thank you and see you later.